Hey, Pre-Calculus. In class, we've been talking about functions, and we'll continue talking about functions for pretty much all of Chapter 2. The definition of a function we didn't talk about necessarily. A function is a rule that assigns each element x in its domain to exactly one element in its range called f of x. So when we talk about f of x, f is the name of the rule. Like you could have Mrs. Lowney of x, you could have Alex of x. This is the name. Might as well write that down. So f is the name. And then the rule might be something like square the number. So to do this, if we think of it as first a mapping diagram, or I think your book calls it an arrow diagram. If the rule is square the number, and anything in the domain, those are my inputs. Domain is another way to say input. For instance, if I had 2 in my domain, then the rule would tell me to square 2. And so 2 would get mapped to 4 because 2 squared is 4. 3 would get mapped to 9 because 3 squared is 9. And numbers like -1 would get mapped to 1 because -1 squared. -1 times -1 is a positive 1. These numbers that we're getting out of our mapping diagram are called the range, or you can also think of them as outputs. Those are two words for the range or output. Now, a mapping diagram is one way to represent a function. A machine diagram is another. So you could think of this as a machine. Functions are like machines. I kind of like to think of them like blenders. Like if you're to make a smoothie, what you put in is fruit, and then you put it into the blender, and you blend it up, and what you get out is smoothie. So in this case, my machine would be called f, that's its name. And what I'm doing is if I plug in something like 4, I'm squaring it, and I'm getting out 16. Or if I plugged in -5, I would square -5 and get out 25. Here again, this is my domain, and this is my range. So you can think of it as a mapping diagram or as a machine diagram. Now you can also represent it using function notation. Here I would say f of x is equal to x squared. The name of the function comes first. This tells you what to input and tells you what to do. So for instance, if I was asked to find f of 2, I would say 2 squared is equal to 4. When I plug 2 in, what I get out is 4. Now, function notation, you could plug in things like a minus 5, perfectly acceptable, and what that just says is that anything inside the parentheses I'm going to square. So a minus 5 squared would be, well, let's see, I have to FOIL, so I'd have a times a is a squared, I'd have a minus 5a and a minus 5a is a minus 10a if I FOILed it out, and then minus 5 is 25. So what I plugged in was a minus 5. What I got out was a squared minus 10a plus 25. Another way you can represent functions is with a graph. So if I were to graph f of x equals x squared, this f of x is really exactly like your y that you've used for a lot longer. It's pretty much the same thing as y. And so if I were to graph y equals x squared in my graphing calculator, obviously you guys know that this would be a parabola. And this is another way of representing your inputs and your outputs. For instance, if I input 1, my output is also going to be 1, because 1 squared is 1. If I input, well, this isn't a very accurate graph. Let's do 0, I guess. 0 squared is 0. And then in theory, if I were to square 2, I would have to go up 1, 2, 3, 4. My graph wasn't perfect. Whatever, though. You guys get the idea. And then finally, the last way that you can represent a function is with an xy table, or an f of x table if you want to be fancy. And this is almost exactly like the mapping diagram. For instance, if I plug in -1 and squared, I get 1. If I plug in 0 and squared, I get 0. 1 squared is 1, 2 squared is 4, etc. So just some different ways that you can represent one concept, one idea. Now, we didn't go over this in the homework, but I wanted to make sure I got it in the notes just in case. If you're asked to find f of -2, this does not mean f times -2. This is a notation that means plug -2 in for x. So what you would do is plug in -2 everywhere you see x, but at the end, your answer is just f of -2 equals. You're not going to divide this. This is not multiplication here. You don't need to get f by itself. So to solve this problem, I'm just going to go through, let's see, -2 squared is 4, and then this is -2 and a minus 5 makes -7. 3 times 4 is 12, minus 7 is 5. So f of -2 equals 5, and that would be my final answer. This means that I plugged -2 into the function, and what I got was 5, input, output. The other day we did see a couple of piecewise functions. Whenever you see a function that has 2 definitions, it's called piecewise. Make sure you get that in your notes, please. A piecewise function is basically a function that's split into 2 or more parts. So it's giving you directions over here. When it says if x is between 0 and 400, we're going to do this. And if x is bigger than 400, we're going to use this part of the function. So when I say f of 50, I have to figure out where 50 is. Well, it's between 0 and 400, so it's going to be 39. So f of 50 is 39. And on this one, I didn't have to do anything. F of 400, well, when I look here, since this is less than or equal to 400, the 400 is going to go with this one and not with this one because it's between 0 and 400. It's right on the endpoint. So this would also be 39. And then for f of 450, now 450 is bigger than 400. 450 is greater than 400. So now I'm going to plug it into this one. So I would say 39 plus 2 times 450. Well, let's see. 2 times 450 is 900. I would get 939 for my answer for that one. Moving on, this is actually a reminder of something that we did earlier in the year, finding the domain of a function. So recall that we can't divide by 0. That would be problematic. So if I want to find the domain of this function, I'm going to set x squared minus x. I'm going to say it cannot equal 0. And then I'm going to factor, since I have a quadratic. I can take an x out. This means that x cannot equal 0, and x minus 1 can also not equal 0. Therefore, x cannot equal 1 if I were to add 1 to both sides here. Now, these are just the numbers that x can't equal, but it really can equal everything else. So think of this as a number line. Here's 0, here's 1. I can't have these, they're open circles, but everything else is perfectly acceptable. All of the other numbers on this number line I can plug into my function and they're going to give me answers, they're going to give me outputs. So my domain for a problem like this, I'm going to shorten it to DOM for domain, will be -infinity to 0, union 0 to 1, union 1 to infinity. This is exactly what we did earlier in the year. We're just going to start seeing it again, coming back to it a little bit. On the next problem, recall that under a square root, the 9 minus x squared has to be positive because we can't square it into a number and get a real answer. To say that algebraically, we would say 9 minus x squared must be greater than or equal to 0. And now here we have a quadratic inequality. So we're going to have to factor and set up our table, or of course you could look at a graph. So if I factor this, let's see, this is a difference of squares, so it'll factors 3 minus x and 3 plus x. And now my zeros are going to occur when x equals, let's see, 3 minus 3 would make that 0, and a -3 would make this 0. So for my table, let's see, where can you guys see what I'm writing? I'm going to write my factors on the side, just like you guys learned in the last chapter. I'm going to set up intervals along the top. So I've got -infinity to -3, that's my 0, -3 to 3, 3 to infinity. Let's see, from here, a number in this interval would be -4. 3 minus a -4 is positive, 3 take away 4 is negative, so overall a plus times a minus is a minus. 0 is in this interval, so I'd have 3 minus 0 is 3, that's a positive, positive, positive. And then here, 3 take away 4 would be negative, 3 plus 4 would be positive, so that's a negative. Now remember, when we make our table, we look back to the original problem. Since it's greater than 0, we know that we're looking for the positive situation. So that tells us I want this for my answer. And since it's an equal to, I'm going to use brackets for my answer. So my domain for this problem would be -3 to 3. Okay. And then finally, we've got a problem, another sort of rational function. Rational because we have a division bar there and some variables in the denominator. here, t can be whatever we want on top, but we can't divide by 0, and we can't have the thing under the square root be negative. So t plus 1 must be strictly greater than 0. Notice I'm not putting an equal to here, because if this thing was 0, we'd have a 0 on the bottom. That means t must be greater than 1, or sorry, negative 1. And so then the domain for this problem would be from negative 1 with a parentheses, since there's no equal to infinity. Alright guys, your practice problems for tonight are out of the textbook, so you're going to have to crack your textbook open. It's on page 155, and I'd like for you guys to do 17, 23, 41, and 49. These practice problems, I'd like for you to do them in your notes, so just directly following the notes that you just wrote down, use the same sheet of paper. And we're going to check these and talk about them in class. Now, if you want to really get ahead of the game, they're all odds, so you can check the answers in the back of the book. Thank you, and I will see you tomorrow.